Hello friends, welcome back. Hearty welcome to you. In this session, let's try to solve one more interesting example related to similar triangles as part of right triangles and similar triangles. So, in the figure we can see a right triangle ABC, right angled at B, and we have a perpendicular drawn from B onto AC, that is BD, and we also have been given that DM is perpendicular to BC and DN is perpendicular to AB. So we have just kept whatever the information given to us, and we see that BMDN or BMDN is a rectangle. Okay, now we have to prove couple of um, points here. One, we have to say dm square equal to dn into mc, another is dn square equal to dm into an. So first we'll consider dm square equal to dn into mc. Now when I want to prove that, I have to take similar triangles from here. So let's try to identify what are the similar triangles in this picture. So for that, I will start with an arbitrary value here and say that value is equal to theta. So you know that this is 90 degrees. Then I have here 90 minus theta. If that is 90 minus theta, this is theta. I have again 90 degrees here. I have so 90 minus theta. You are okay with that, right? Because some angle, some property tells that it's always 180 degrees. So if this is theta and 90, then this should be 90 minus theta. And again we know this total angle is 90. So this becomes again theta. So if we do like that, we can identify all the angles and we can see what are the similar triangles we have. So we have one more 90 here. Then we have theta here. And we have 90 minus theta. Now you can see all these triangles 1, 2, 3, 4 are similar to each other. We have all the 4 triangles similar to the big triangle ABC, because all of them have angles theta, 90, 90 minus theta. Now the point is, we have to understand which triangles I have to consider so that I can prove what is needed. I need dm square equal to dn into mc. Now where is mc? mc is in triangle DMC. Triangle DMC. So let me write down that first triangle we'll consider is triangle DMC. Now we have to take another triangle which is similar to DMC, and DMC when we took, we started with 90 minus theta, 90 theta. So we have to go in the same order for another triangle where we have DM and DN. So DM and DN is available in either one of these triangles. Either BMD I can take, or I can take BND. Why? Because it's a rectangle, so we know BM equal to ND and BN equal to MD. So for simplicity, we will take this triangle BMD. We have to start from 90 minus theta, 90 theta. That is how we did DMC. So it will be BMD. Triangle BMD. They are similar to each other by a similarity. So let's try to find out the corresponding sides. So in the proportion they will be, we know that. So can I write down dm by bm is equal to mc by md. That's nothing but equal to dm. Now what is bm? bm is equal to dn. We know bm equal to dn because BMDN is a rectangle. We have all interior angles are 90 degrees. Okay. Now if we substitute BM equal to DN, we will have DM by DN equal to MC by DM. If you do cross multiplication, you will get dm square is equal to dn into MC. That is what we have to prove. So in this type of problems, first we have to identify all the similar triangles by taking arbitrary angles, or there are so many other ways. You can look at the common angle between the triangles and you can do that. I prefer to start with an arbitrary value so that it's pretty clear to me, very clearly evident to me, that what are the corresponding angles which are equal. So then we have observed here that the triangle DMC is similar to triangle BMD because both of them have 90 minus theta and 90 theta angles. So then we can say that corresponding sides are in proportion. Since we know they are similar triangles, their corresponding sides should be in proportion. So we have written that and we got the first result. Now let's try to find out the second result. Now the second result we have to prove is dn square equal to dm into an. So let's look at the triangles which I need to consider. I need an, so I have to mandatory take this triangle AND. So let me write it down, 90 minus theta, 90 theta. So I will say triangle AND. What will be its counterpart which I need to consider for other similar triangle I want? I have dn square equal to dm into an. So where I have dm and where I have dn, I know dm equal to bn, so I can take triangle BND, but I have to write in angles 90 minus theta, 90 theta. So that will be 90 minus theta, 90 theta, which is nothing but DNB. I hope that's clear. Always remember the corresponding angles are equal in similar triangles. So when you write down the triangle names, you have to be pretty clear that the corresponding angles are same. Angle A equal to angle D equal to 90 minus theta. Angle N equal to angle N, 90 degrees. Angle D is equal to theta. Angle B is also equal to theta. Now let's try to write down the corresponding sides which are in proportion. I will have AN divided by DN equal to ND divided by NB. Now we know that NB is equal to DM. We know BN equal to DM. Since BMDN is a rectangle, let's say this is 1. We'll say 1 here. We'll refer to 1 here. BMDN is a rectangle. Now if we substitute, what we'll have? We'll have AN divided by DN. AN divided by DN is equal to ND, or can I say DN divided by BN, which is nothing but equal to DM, because BMDN is a rectangle. We have all interior angles 90 degrees. So when you do cross multiplication, you will get dn square equal to dm into an. So to solve this type of problems, always remember you have to identify the similar triangles. Once you identify the similar triangles, you have to pick the right similar triangles. To identify the right similar triangles, always look at what you need to prove. From that you will get a hint that what are the triangles you have to consider. Now if you look at the first one, it says MC. MC is only here and MC is not equal to anything else. So DMC triangle is mandatory. I have to take it. Now the other one I need DN. So DN is on this triangle BND, or I also have triangle BMD because DN equal to BM. So any one of them I can consider. Okay, similarly dn square equal to dm into an. An is a side which is not there anywhere. So mandatory I have to take triangle AND. The other triangle should have dm and also dn. So that comes from either one of the triangle BND or triangle BMD. So I'll solve some more interesting example as part of similar triangles in the coming sessions. Thanks for your time and support. Bye for now.